Hey guys, this looks like a fun one. We're given a pattern of 1, 2, 3, 4, 5, 6, and it's asking what is next. A lot of people would say 7, and that makes sense because you're increasing by 1 each time. So to have a little bit of fun with it, I also thought of something like R could work. Reminds me of a Honda Civic Type R shift knob. It would go 1, 2, 3, 4, 5, 6, R. I wonder if that's why they call it a Honda Civic Type R. And this guy's saying it can be anything. He's given the example that he can make it 42,069. You want to see the math behind how he can make this 42,069? If you want to try it on your own, pause it right now because I'm going to do it in 3, 2, 1. First, we can graph this pattern. In the place of the X, we can put the term number, and in place of Y, we can put the term value. So we can do 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And that's these points right here. A lot of people say 7, 7. That makes sense. But this guy is saying 7, 42,069. That's going to be way up really high. That's 7, 42,069. So let's see, how do you find an equation that'll go through all of these points down here, but then also this one way up here? So we're trying to find some equation f of x that'll go through all of these points. Well, first let's deal with 1, 2, 3, 4, 5, and 6. That'll just be f of x equals x. The term value is equal to the term number. So let's start with that down here. F of x equals x. That'll take care of all of these 6. And then to get this one, we're going to have to add some value of c. But we need this c to be 0 for all 6 of these points. So we're going to multiply that c times x minus 1 times x minus 2 times x minus 3, x minus 4, x minus 5, x minus 6. The reason we want to multiply by this is if we have, for example, 1, this will become 0 and the whole thing goes away. Actually, it might be easier if I just show you really quick. To do f of 1, in the place of x, we plug in 1, and then we'll do plus c. And in the place of all the other x's, we'll plug in 1s. This 1 minus 1 is equal to 0, so all of this is going to be multiplied by 0, so it all disappears. So now we have f of 1 equals 1. And then we can do the same thing for f of 2. In the place of all the x's, we're going to plug in 2. This binomial, when you do 2 minus 2, is equal to 0, which means all of this is going to disappear. So we have f of 2 is equal to 2. And the same thing is going to happen for f of 3, f of 4, f of 5, and f of 6. For the f of 3, this 3 minus 3 is 0. For the f of 4, the 4 minus 4 is 0. For this one, 5 minus 5 is 0. And for this one, 6 minus 6 is 0. So all of these with the c's are going to disappear. Pretty cool, huh? And now let's do f of 7. In the place of this x, we can plug in 7. And same thing for all the x's, we can plug in 7. 7 minus 1 is 6. 7 minus 2 is 5. 4, 3, 2, and 7 minus 6 is equal to 1. We can multiply all these together and it gives us 6 factorial, which is equal to 720. And now we just got to solve for c that'll make this one true. In the place of f of 7, we can plug in 42,069. And we can copy down the right-hand side. Next, we can subtract 7 from both sides. On the left-hand side, we'll end up with 42,062. And on the right-hand side, these are going to cancel, leaving us with c times 720. Next, we can divide both sides by 720, and that gives us c is equal to 21,031 over 360. And that is our value for c. So in this f of x, in the place of c, we can plug in this. And that is the answer to our question. This function will go through 1, 2, 3, 4, 5, 6, and then 42,069. You want to see it in Desmos? And here it is in Desmos. We can see that it goes through 1, 1. It goes through 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And if we zoom way out, we can see if it goes through 42,069. Okay, there's 42,069. Does it go through it? And it does go right through it. 7, 42,069. Isn't that cool? So this function will make this guy's pattern correct. 1, 2, 3, 4, 5, 6, 42,069. How exciting.